Have you ever wondered how your computer or smartphone works? These devices power our world, helping us learn, create, and connect. Classical computers, as we call them, are the brains behind everything from the internet to your favorite games. But what makes them tick? At their core, computers are masters at following instructions, like a super fast recipe book. You give them a program, and they follow each step perfectly, billions of times per second. Every action, from clicking a mouse to loading a website, is just a series of simple steps executed at lightning speed. Imagine building with Legos. A computer breaks big problems into tiny steps, handling each one in order. This step-by-step process is why computers are so reliable and precise. Over time, these machines have become smaller, faster, and more powerful, revolutionizing everything from medicine to entertainment. But as powerful as they are, scientists are dreaming even bigger, exploring a new frontier that could solve problems too complex for today's computers. Welcome to the mysterious world of quantum computing. To truly understand the power and limitations of computers, we need to delve into the very foundation of how they operate. We need to learn their secret language. It's a language of just two symbols, a seemingly simple system that underpins all the digital complexity we see around us: 0 and 1. Each 0 or 1 is called a bit, the fundamental building block of information. It's the smallest unit of data in a classical computer, the atom of the digital world. Think of a bit as a tiny switch, a fundamental element that can be in one of two states. Off means 0, on means 1. Inside your computer, billions of these switches combine, working in concert to perform complex calculations and operations. To represent everything, from the simplest text to the most intricate graphics. Letters, colors, sounds. It's like a secret code made from just two symbols, a language that computers understand fluently, read and changed at incredible speed, allowing for the rapid processing of information. Imagine sending a message with a flashlight, using flashes to convey information. Off for 0, on for 1. Computers do this with billions of microscopic switches packed onto tiny silicon chips, billions of times per second, enabling them to perform complex tasks with remarkable efficiency. This simple system lets computers store files, run programs, and connect to the internet. The bit's black and white logic makes classical computers reliable and powerful for many tasks, from everyday word processing to complex simulations. But this on or off limitation also holds them back, preventing them from tackling certain types of problems effectively. From solving some of the world's most complex problems that require exploring a vast number of possibilities simultaneously. Nature isn't always so simple, and many real-world phenomena exist in a state of flux, somewhere between on and off. Sometimes we need more than just 0 or 1, we need to represent the shades of gray in between. To tackle those challenges, we need a new kind of bit, one that can capture the nuances and complexities of the natural world. One that can exist in a much stranger state, a state that defies the limitations of classical bits. This is where our journey into the quantum world truly begins, a realm of superposition and entanglement. Get ready to meet the qubit, the quantum bit that will revolutionize computation. The adventure is about to get weird. Prepare to have your understanding of computation challenged. Imagine a computer so powerful, a machine capable of calculations beyond our current comprehension. Imagine it could help us discover new medicines, unlocking cures for diseases that plague humanity, and revolutionizing healthcare as we know it. Or perhaps create amazing materials, with properties we can only dream of today, leading to innovations in engineering and construction. And even solve mysteries of the universe, peering into the cosmos to unravel the secrets of dark matter and the origins of existence. This is the promise of quantum computing, a field poised to redefine what's possible. It's a completely different kind of machine, not just faster, but fundamentally distinct in its approach to computation. It's based on the strange rules of quantum mechanics, a realm where the familiar laws of physics bend and break. Classical computers use bits, on or off, 0 or 1, a simple binary choice. But in the quantum realm, things get weird, defying our everyday intuition. Tiny particles can be in multiple places at once, a concept known as superposition. They can also be mysteriously connected across distances, a phenomenon called quantum entanglement. Quantum computers harness these behaviors, exploiting the quirks of quantum mechanics. They use these principles to process information in revolutionary ways, opening up new avenues for computation. Instead of thinking in black and white with definitive answers, they explore a whole spectrum of possibilities at once, considering every shade of gray. Picture a giant maze, a complex labyrinth with countless paths. A classical computer tries one path at a time, methodically working its way through. But a quantum computer explores all paths simultaneously, instantly assessing every option. This ability to look at many possibilities at once in parallel gives quantum computers their incredible potential, unlocking solutions previously out of reach. They're not meant to replace your laptop for everyday tasks and browsing the internet. They are designed to tackle problems that are impossible for classical computers, pushing the boundaries of scientific discovery. Quantum computing is a leap into a new era, a paradigm shift in how we approach computation. It's reshaping science, technology, and our understanding of the world, promising a future filled with unprecedented innovation. If the bit is the hero of classical computers, representing information as either a 0 or a 1, a simple on or off, the qubit is the superstar of the quantum world, a realm where the rules are bent and possibilities expand beyond our everyday understanding. A qubit, or quantum bit, is the basic unit of information in a quantum computer, the fundamental building block upon which quantum computations are built. Like a bit, a qubit can be 0 or 1, representing those familiar states. But here's the magic, the truly mind-bending part. It can also be both at the same time. It exists in a state of uncertainty, a blend of possibilities. Imagine a spinning coin suspended in midair while it spins. It's not just heads or tails, it's both, a probabilistic mix of both outcomes, until you catch it. The act of observation forces it to choose a state. This both-at-once state is called superposition, a fundamental concept in quantum mechanics, and it's what gives qubits their extraordinary power. It allows them to perform calculations in ways classical bits simply can't. With each added qubit, the amount of information grows exponentially, doubling with every addition. Just a few qubits can represent more possibilities than there are atoms in the universe. It's a truly staggering amount of potential. So, while a bit gives a simple yes or no, a definitive answer, a qubit gives a maybe that contains all possibilities. It's not indecisive, but rather it holds all the cards. Quantum computers manipulate these spinning coins, these qubits in superposition, exploring a vast landscape of answers at once. They can analyze countless scenarios simultaneously. The qubit is the heart of quantum computing, the engine that drives this revolutionary technology, unlocking a new way to store and process information. It's a paradigm shift in computation. Understanding the qubit is key, the first step to unlocking the power of this amazing technology. It's the gateway to a new era of problem solving. It's a whole new way of thinking about information, a departure from the classical approach. Ready to see what else a qubit can do? Let's dive deeper into the quantum realm. Let's dive into a qubit's first superpower, superposition. Superposition means a qubit can be both 0 and 1 at the same time, a bit like holding two snacks in your mind at once. Classical computers consider options one after another. A qubit holds all possibilities at once. When you measure a qubit, the superposition collapses into a definite answer, 0 or 1. Think of a guitar string. When plucked, it vibrates in a mix of notes, not just one. That's superposition, a blend of possibilities. Quantum computers control these delicate vibrations, guiding them through calculations. Superposition lets quantum computers represent millions of combinations at once. With many qubits in superposition, it's like having millions of classical computers working in parallel. This is what gives quantum computers their massive speed for certain problems. Superposition is a fundamental shift, processing information all at once, not step by step. It's the engine behind quantum computing's power. But there's another superpower, entanglement. Let's see how it works. If superposition is a qubit's first superpower, entanglement is its second, and it's even stranger. Entanglement links two or more qubits so their states are connected, no matter how far apart they are. Measure one, and you instantly know the state of the other, even across galaxies. It's like having magic coins. Flip one on Earth, and its twin on the moon instantly matches. Entanglement lets qubits share information and work together in ways classical bits never could. This spooky connection creates a powerful web, boosting a quantum computer's capabilities. Entanglement is key to solving problems that stump classical computers, like breaking codes or simulating molecules. It's not just a curiosity, it's a vital resource for quantum computing. By controlling entanglement, scientists unlock new ways to solve complex problems. Together, superposition and entanglement make quantum computers truly revolutionary. So, what can quantum computers actually do? They're not for playing games or browsing the web. Classical computers are great at that. Quantum computers are specialists, tackling problems too complex for any other machine. In medicine, they could simulate molecules to design new drugs and materials, speeding up cures and inventions. In logistics, they could find the most efficient routes for deliveries or flights, saving time, money, and energy. Quantum computers could revolutionize artificial intelligence, making smarter, faster decisions. They could analyze financial markets, model climate change, and solve optimization puzzles that stump today's computers. The potential is vast. Quantum computers could help solve humanity's biggest challenges. They're a new tool for understanding and shaping our world. The quantum future is full of possibilities. If quantum computers are so powerful, why aren't they everywhere? Their superpowers, superposition and entanglement, are incredibly delicate. The slightest disturbance can disrupt them, a problem called decoherence. To protect qubits, quantum computers must be kept ultra-cold and shielded from interference, making them huge, expensive, and tricky to build. We're still in the early days, like the first room-sized classical computers. Controlling many qubits and keeping them error-free is a huge challenge. Scientists are developing error correction techniques and learning how to program these new machines. It takes a new way of thinking and a lot of brilliant work to unlock their full power. Overcoming these hurdles will take time, but progress is happening fast. The quantum revolution is just beginning. Despite the challenges, the future of quantum computing is bright. We're at the start of a new technological revolution, with rapid progress every year. Soon, classical and quantum computers will work together, each doing what they do best. This partnership will bring quantum power to real-world problems before we have universal quantum computers. The impact will touch medicine, energy, AI, and more. Even if you never own a quantum computer, quantum discoveries will lead to a healthier, more sustainable, and more prosperous world. It will accelerate science and help us answer big questions about our universe. Don't be intimidated. Think of quantum computing as a grand adventure into a new scientific frontier. The story is just beginning and we're all part of it. The quantum age is coming, and it's going to be amazing.